Alright, welcome back to a new TouchDesigner tutorial. And in this one we are creating some beautiful particle shapes or particle paths using the newish particlesGPU component from the 2022 TouchDesigner version. And yeah, we're going to use some forces and some lookups here for this particlesGPU to create this output that you can see here on the left. And generally the particlesGPU is just a lot of fun to work with, and we're gonna look at this in several videos now actually. So yeah, without further ado, let's just get started. So as always, I'm just gonna delete my entire network, and we're gonna start with the particlesGPU. Before we get started, however, I've actually set my FPS to 120. So if you have a decent graphics card, that should be no problem. It doesn't really run that well right now when I'm recording, but usually it runs smoothly with 120. And especially when you're working then with feedback to add some trails, it's a much smoother and nicer experience. So I can recommend that. All right, so I'm gonna open my palette, go to Tools, particlesGPU, and just drag that in my network. And let's just have a closer look here. Just gonna close this for now. All right, so by default, this is the example, some leaves falling down. Depending on your version of TouchDesigner, you might see a different example, but it should still all work well. So what you might notice here is that we don't have the sub input, and we've gotten a lot of questions about that on my Audio Directive Particle Cloud. So we're going to look at that in another video. For this one, we can actually use the default examples here, or like some default shapes to spawn the particles or to birth the particles. So I'm just going to hit A and H in here. So I've got my camera centered. And I'm going to get rid of my post translation here. So my rectangle right now is in the center. And then I'm going to actually change my shape to a circle. So a sphere would also work, but in this case I'm actually going to work with a circle. And I want this to be in the XY plane. So it's looking to us. I'm going to change the radius to 0.2 on all axes. So now we have a circle that spawns the particles in the center of our screen, pretty much. Cool. So one thing we might want to do now is change the material. I don't actually want to have leaves in there, so I'm going to change my material to line. And this might be a bit confusing because it doesn't actually create lines but points when I change it to line material. It's because if we go in here, we can see that there's several materials in here, and one of them is the line mat. And in there is actually lines are turned off and the points are turned on. So it's a bit confusing, but yeah, if you select a line, it actually draws points. So on my render, I'm going to change my resolution to 1280 by 1280. So we have a square format. And you can see that actually distorts this image here. That's because on our layout, our component is actually set to 1280 by 720. So we've got to adapt that. So we now got a square. As we're working with a spherical shape in the end, I think a square is working very well. So let's go to our particlesGPU main page here. And let's change a few things here. So first off, I'm going to change my birth to 500. So 500 particles are being born every frame we created. And this is actually a great change to the previous version, because what we had there is only the total number of particles. And you can see that there's a problem here if we can maybe change this to a higher number. There's always like a batch of particles being spawned, and then there's a while of kind of barely any, and then like a bunch again. So it's much nicer to change this to particles by frame, because it's like evenly distributed. I'm actually going to change my life and life I'm not going to change my life. I'm going to change the particles life expectancy to 5 units or seconds, I think. And then the life variance also to 5. So they're not all the same age, pretty much. Okay, so I'm going to turn off display bounds. We don't actually need bounds here. And I'm going to change the hit behavior to none. So now you can see they're growing a bit larger. And on my render, I'm actually also going to change the fade in and fade out to 0.1 and 0.9. And what this means is these are fractions of their life. So if until they're 0.1 fractions old, they're going to be fading in. And after they're 0.9 fractions old, they're gonna fade out. Another thing here is that I also want to add a keyboard in shop. So I can nicely, just like in any feedback loop, nicely reset my network. So if I hit 1 now on my keyboard, it's gonna reset everything. Yeah, we might want to come back here, but for now, let's have a look at the forces. So right now you can see the particles are actually flowing down. That's because our external force here is set to -1, so it's kind of like gravity. So if I were to change this to 0, hit 1, you can see they're not actually going anywhere. They're just kind of being created here randomly on this circle. Just gonna go back and show you the turbulence, because this is what we're gonna be working with, and this is probably the most fun part about this whole thing. So I'm gonna go up with my strength here, the x, to 0.5, and now you can already see the turbulence happening here. Right now it's a very small period, but if we go up with the period, you can maybe see it a bit better. It looks pretty interesting, right? So right now actually the turbulence, so kind of the noise field that's being created, doesn't actually change. We're not transforming it here in any way. We're transforming y and z. So let me just show you. If I increase y, maybe even to like +1, you can see now on the y-axis it's also changing the particles' paths. So yeah, you can really play around with this already quite a lot. We're going to do that, but we're not going to be working in constant mode. So we have these different types here, and I'm going to show you how to work with them now in a minute. So I'm just going to get rid of the turbulence magnitude here, so we don't have any turbulence. We basically want to grab these particles now and kind of pull them outwards. So because now they're just literally staying there in the center and nothing is happening. So what we can do, we can make use of the extra forces. And you can see it's a chop that is referenced inside of the network. So there's a bunch of these here that they're grayed out right now. If I were to change this to velocity, you can see null wind is also in there. So let's go in here and check what that's about. We can find our null extra here that we saw here, right? Null extra. If we go in here, we can find the default force definition here. And I'm just going to copy this, go back out, and paste that in here. So let's just get rid of the expression here. And then instead of this reference, we can just drag this on here. And now we're referencing this. Okay, so what is this actually doing? Currently, it's not actually doing anything because the force amount is set to 0. So we can actually create several instances of these forces and define their position, their radius, amount, force type, and also their direction, depending on the force type that's relevant. So we can go in here and go down here, and we can see we have these 4 different types: radial, axial, vortex, and spiral. For now, we're just going to be working with radial, but definitely check out the other types as well. So as radial is force type 0, we don't have to change anything here. Right now we don't see anything happening because the force amount is set to 0. So let's just set that to 1. Okay, it looks like something is happening. The thing is, the force that we're working with right now is actually pushing all the particles to the center. So we want to just invert that, and so we can just type in -1. And now you can see all the particles are being dragged out. Before we go on, I just want to change my size here to like 0.9 and 0.1 and 0.9. So random value between 0.1 and 0.9. So just a lot smaller. It looks already much better. Cool. So that's already very nice, right? So we have a spawn point and just a force that is pulling all of these particles out. So we might want to change our force radius to 2 actually, so they're being pulled out a bit further. Just pressing H here. Yeah, mood down here. Well, okay, so I'm just pulling out the particles. Now you might already be guessing how we can work, or how we can continue working, because now we have a nice spherical shape here. So now we can just add turbulence. So I'm just going to put this back into the mix. And it's already creating a very interesting look. So we might want to turn off display extra forces so we can see this nicely. And also, let's just quickly set this up so it's proper. Just gonna add a null here, call this BG, split my pane, my internal pane. My god. Top viewer, I'm just gonna turn this on here. And right click, display, backdrop tops off. Alright, so we can nicely see our particles here on the left. So this is already looking quite interesting, and there's already a lot of room to mess around with the different turbulence forces here, so feel free to just at this stage already play around quite a bit. But actually what we want to do now is we want to use this chop down here. So we've got to change this to, we're going to work with velocity. So basically the speed at which the particles are moving. So now you can see something happened, and you probably don't know why that happened. So if again, we were referencing a lookup chop here, /null_turb, and actually we can find that in here. So let's just copy this and paste it outside of the particlesGPU again. And let's just get rid of all of these expressions. We don't need this to be animated. What's happening here is that technically we could just start with 1, I guess, so it's kind of easier to understand. Basically what we're doing here, we're taking all of these parameters that we had before, right? Turbulence on X, Y, Z, magnitude, period, seed, and then the transforms, and we're just putting them into a constant. And in this constant now we can define the same values. So if I were to put this on here now, you can see it goes back to the original state because our magnitude is actually set to 0. So if I maybe put this to like 0.5, you can now see there's some stuff happening. We can go up with our period. It's pretty much the same thing as we would do before. We're only defining one thing, so whatever the velocity is, it's still going to be the same values here. So that's why we're doing these different constants. So basically what we're doing here is we're creating different sample points, each with like different values in it, or channels. So one sample channels, you could say, and then we're joining them together. So now if I were to put this in here, you can see that things are changing again. So basically what we're saying here is when velocity is low or 0, then we're using these turbulence values. And if they're very high, we're using, like if the velocity is the highest, maximum, then we're using these values here, and this is the in between. So we're basically just saying it's like a lookup, right? So low velocity here, high velocity here, and for each stage we're defining different options for the turbulence pretty much. Okay, so let's just have a look at some good values here. So I'm just going to change these to like 0.1, 0.2, and then here I'm going to change it to 0.8 and 0.3 maybe, and then on the last one, 1 and 0.03. So these are just values I found out, they're very nice. So again, you can just, as always, mess around with these. That's really where the fun starts. You don't even technically have to fully understand what's happening here to mess around with these, but of course it's always better to understand it. You can also change it to h. So right now the lookup is happening based on the speed, the velocity of the particles, but now it could also be changed to h. So basically here's the turbulence options when they're born, and here's when they die. Hope that makes sense. But I think velocity works a lot better. There's also these effectors, but we're not going to look at those in this video. So that is looking pretty interesting. Let's have a look at color. So for color, we also have to work with a ramp lookup. So it's looking nice. We can also set a constant or random. We can also define our input here. So we could add a ramp and put that in there. So they're either going to be, I'm just going to quickly some color here. So either going to be green or red now. But I don't really like the way that looks. The cool thing is that we can, again, create a lookup, and this time we're going to do it based on age. So there's actually, again, already a lookup that is defined here, point/null color. So again, if we go in here, we can see null color is down here. It's actually based on a pattern chop. We don't want to base it on a pattern chop because that does give us a lot of option to play with, or it's not very intuitive. So I'm just going to use a ramp here that we've already created. And I'm just going to add a null top2 chop because we have to define a chop at the end. I'm just going to call this color and put that on here. So now you can see we're using these colors. The weird thing about this is that the lookup is happening in reverse. So for some reason, when they're born, they're getting the color on the right, and then when they die, they're becoming the color on the left. I have no idea why that is that way, but it is, so we have to accept it for now. So I'm gonna create a bit of a different ramp here. So like similar colors, but like a bit darker red, then like a sort of orangey color here, like the greenish color here, and then like a bright color here at the end. So it's kind of looks like it's glowing in the center. Something like that. You can still adapt that later on. A very nice thing here is also that you can rotate this in 3D space, right? We're not just working in 2D space. We were working in 3D, so this is actually really looking like a neuron or something. It's very nice, very fun to play with. And yeah, you can also, as I said in the beginning, you can try a different shape here. So you could also try sphere. Might even be nicer, depending on what you want, really. So I think for the 2D look at the end, if you want that, when we're going to look at that in a second, the circle works a bit better. If you want to work in 3D, then the sphere, of course, is kind of nicer because it's more evenly distributed in all directions. I'm just going to go back to circle for this example. So we're going to add some post-processing and then some other things here. So let's push this to the very end. And I'm just going to go to my palette and just drag in a simple feedback here that I created. I think you should be able to do this on your own at this point. I've done that so many times. I'm going to change my opacity to 0.95 and the operation is set to over. So now you can see it creates these nice trails, right? And we can make these trails even more prominent if we go here to particlesGPU and change our speed to 2 or even higher. At some point you're going to really see the feedback, so I wouldn't go too high. But generally this is a very nice effect, like kind of you can do this slow motion. So it's a very cool feature to have this speed. We should have this on a lot more operators, actually. So that's looking nice. I'm going to make this a bit bigger so you can see it a bit better. Also, this is a project where the bloom works very nicely on. So you can just go to image filters, bloom, drag that in here, and connect it to our network. First, it looks kind of meh, but if we change a few things, we can make it look quite nice. So first off, I'm gonna change my threshold to like 0.06 and my intensity to like 0.1, and maybe the level a bit. I can play around with that. And the glow level, can maybe want to have a different glow color. So yeah, kind of triggers me that you always have to reconnect it with these. But as you can see, it just looks a bit cooler. Another trick that we can do here to add like a bit of 3D feel is, first off, we might want to add a level actually, because you might not be able to see that here. But if you look here, you can see these kind of trails that just stay there, because that's kind of an issue when you do feedback with the opacity technique, that these trails at the very low opacity just stay there. So what we can do is simply add like some in low here, like a 0.01 or maybe 0.02 depending. So it basically gets rid of those. It's just a bit cleaner. Then what we can also do is add a blur here. So we're just gonna make it look a bit 3D-ish now. Like a blur, an emboss, channel mix, and a level. and a composite here, and change the operation to over, put that in here and swap the operation order. I'm going to select my emboss here and go down with the midpoint and up with the strength to like 100. On my channel mix, I'm going to get rid of my alpha. And on my level, I'm going to go down with the opacity to like 0.05. And I'm going to increase my pre-shrink and filter size here. So now on the opacity, you can actually, if you increase this, you can kind of see the 3D effect taking place there, being added. If you do this very subtly, I think it looks very nice. So you can just see like an AB here. I think it looks kind of cool, but if you go too high, it just looks really cheap, actually. I think it's about the subtleties, right? Alongside other things. You might want to add some LUTs at the end, or, you know, I have videos on that. Any kind of post-processing. But let's have a look at what else we can do in here. So first off, we can add an LFO. Actually, let me just show you without. So we have the force radius here, right? And a very cool effect is to make it smaller, like not too small, and then bigger again. So it's kind of like this explosion, or like it's breathing. So yeah, I've added this LFO. I can add a math, rearrange that from -1 to 1, and then 0.7 and 2, I think, work well. Let's add a null. Let's just call this radius. And use this channel on the force radius. So now you can see it's kind of breathing. Might want to zoom in a bit more. Looks cool. I'm just going to turn this off for a second. One other thing we can do here is that we have this turb seed. So if we change that, it's going to change our roots or wires or whatever you want to call it here. So same with any of these. So like if we change that turb seed, we can add a bit more dynamics. So one way to do this would be to add another LFO, change it to pulse. Let's go down with the frequency to like 0.2. Let's add a count as well as a null. Let's just call it seed. And on both of these, we might want to just add this. Let's just add like +1 here, so we have a different seed. So every time this hits now, everything is going to sort of change to a new seed, which I think makes it a bit more interesting over time. Kind of like rearranging the particles once in a while. All right, so that's really it. You can play around with all of these forces and different materials as well if you want. Like, you know, you don't just have points then, or any kind of post-processing. Really play around with these extensively, and also check out, you know, like wind and external types and these kind of things. And in the next videos, we're also going to look at some audio reactivity and using the optical flow. So yeah, I hope you enjoyed this video, and thanks a lot for all of the support I'm getting on Patreon. I'm really thankful, and I see you on the next video.